Hey, this is Mr. Aiden. We are in Chapter 3, that's Exponentials and Logarithmic Functions, and we're in Section 3.3, Properties of Logarithms. And this will work for logarithms, natural logarithms, and these properties go far beyond our pre-calculus studies. Now, if you have a calculator like the calculator on the left, just a regular scientific calculator, you have what looks like a log button. You can see right here where it says log and 10 to the x, that is the inverse of each other, that log and 10 to the x, and we have natural log and e to the x right there. And so you can do each of those terms that way, but if you see with log, it will only say log of some number, okay? And so you're really doing log base 10 with those kind of calculators. But if you have a calculator like TI Inspire, CAS, many of the newer TI-84 graphing calculators, you can see right here, we have our 10 to the x, we have our log, we have our e to the x, we have our natural log. And if you do logs in these calculators, it will give you log with some base, log with some base. So you can do base 8, base 10, you can do whatever for your logarithms for these calculators. Now, if you don't have a log calculator that does bases, you can use what's called the change of base formula. And so with the change of base formula, you can literally do it in terms of log base 10 or even log base e, which is natural log. And so you can do, if you have log base a of x, you can do log of x over log of a, or natural log of x over natural log of a. So let me give you two real quick examples here. In example 1, which is using our change of base formula. So we have our log base 4 of 25, which means we can do log of 10 of 25 over log of 10 of 4, okay, which is the same in your calculator as log of 25 over log of 4. So if you do log of 25 divided by log of 4, you end up getting 2.321928, so on and so forth. And so that is how you would do this change of base on your calculator. Now you can also use natural logarithms. So you can do natural log of 12 over natural log of 2 for log base 2 of 12. And so you can do natural log of 12 divided by natural log of 2, and you end up getting 3.5849625, and you can try that in your calculator. So if you don't have a calculator that does bases, log bases, then you can literally do it using the change of base formula. Okay. Now we have some properties of logarithms. Properties of logs, like they come from trees and they have bark on them, and other properties of logarithms, which is 3 properties. One is called the product property. That's when we have something being multiplied, u times v, and that multiplied will become adding. That multiplied will become adding. Same with natural logarithms. Multiplying will become adding. Okay. You can see if multiplying is adding, then a quotient, dividing is going to be subtracting, or dividing is going to be subtracting right there. Which means if multiplying is adding and quotients or dividing is subtracting, then powers, a power to the n power would be like multiplying. A power to the n power would be like multiplying. And so we can apply these properties of logarithms. Let's take a look at an example. We're going to write each of these logarithms in terms of natural log of 2 and natural log of 3. Now you can see natural log of 6 is the same as natural log of 2 times 3. So that is just like our u times our v in the last formula, which means we'll have natural log of 2. Remember, the multiplying is synonymous with adding in our properties of logarithms, natural log of 3. So if you took natural log of 2 on your calculator plus natural log of 3 on your calculator, it would be the same as natural log of 6 in your calculator. Okay. Now on this one, we have natural log of 2 divided by 27. And so what is 27? Is our 27 is 3 to the third power. 3 to the third power. Okay. And so we're going to break this up. We're going to do what's called expanding it. So we have natural log of 2. Okay, we're dividing. So dividing is just like subtracting. And we have natural log of 3. And this 3 is an exponent. So exponent will become our multiplying there. So again, we were taking that 2, dividing. Dividing is synonymous with subtracting. On the denominator, we have 3 to the 3rd power, which is 3 natural log of 3. Now, you might say, whoa, Aiden, what if you call this natural log of 2 divided by 3 times 3 times 3? Okay, now let's think about that. We have natural log of 2 minus, this is all in the denominator, so we have minus natural log of 3, minus natural log of 3, minus natural log of 3. Why do we do minus, minus, minus? Because they were all in the denominator, and you can see we can group these together to be minus 3 natural log of 3. So those properties work out over and over and over again. So let's take a look at what we call expanding. Expanding means we're going to take this logarithm and we're going to expand it through. So when we expand it, we keep the same base. So we have log base 4 of 5. We're multiplied by x squared. So multiplying is synonymous with adding. Not x squared, x cubed. That cubed is like multiplying 3 times log base 4 of x plus, because we're multiplying again, log base 4 of y right there. And so you can see that has been expanded. Our log base 4 is in every single term. Our 5, our x, our y are all being multiplied. Our 3 is the power of cubed. Okay, we're going to do the same thing here. So here we have natural log. I'm just going to expand it a little bit, and then I'm going to keep expanding it. Natural log of the square root of 3x minus 5 minus, because that's on the denominator, minus natural log of 7. Okay, now let's think about this guy right here. He is really 3x minus 5 to the 1/2 power minus natural log of 7. What do we know? What do we do with powers? Powers are going to be multiplied. So that 1/2 is going to come out from natural log of 3x minus 5 minus natural log of 7. And you might say, Aiden, is there anything we can do in here? There's not. That is going to stay just as 1/2 of natural log of 3x minus 5 minus natural log of 7. Now, if we can expand, we can also do what's called condensing. So how I like to condense is I like to see what my term is. You can see log base 10 is the common term, so log base 10. And we're going to combine these together. So let's take a look at the first one. That 1/2 is in front, so remember multiplying is going to be like exponents, so that is going to be x to the 1/2 power, or square root of x. And then you can see right here we have x plus 1, and that 3 is in front, so that's going to be a cubed on that guy. And so we have log base 10 of the square root of x times x plus 1 cubed. Okay, let's take a look here. What's our common factor within these things is the natural log. So I just put a natural log. Now I go to what's inside here. So what do we have? We have x plus 2. And that 2 is in front, so that's going to be an exponent, so it's going to be squared. Minus, what is minus? Minus is dividing. And what are we dividing by is an x on the denominator right there. And so that is the condensing of that logarithmic expression. Okay. So now on this last one right here, we have 1/3 log base 2 of x plus log base 2 of x minus 4. So that 1/3 is out front. What is the common factor involved here is log base 2. Okay, we have x, so I'm going to put an x, plus is just like multiplying. We have x minus 4, so we have x minus 4 right there. And we have that 1/3 out front, in front of all of that. So what do we know about a 1/3? Multiplying is that's going to be a power to all of this inside here. Okay, and so that is going to be equal to log base 2 of x times x minus 4 and that's going to be the cubed root, or the 1/3 power, or the cubed root right there. And so we went to expanding, we went to condensing logarithmic functions, and that is section 3.3, properties of logarithms. So hopefully that helped. I'll catch you on the flip side. See you guys.